Hey there, welcome to Joey's Dynamic Programming tutorial. In this video, you are going to learn how to solve the longest string chain problem which I have taken from the LEETCODE's website. I will solve the longest string chain problem using the dynamic programming technique because this pretty style of solving computing problems saves me from the hassle of coming up with complex strategies every time to solve new problems. Now let's take a look at its problem statement. You are given an array of words of lowercase letters. You can check the array below we are going to work upon in this video. This problem is all about the word chain, so you got to understand first what a word chain is. A word chain is a sequence of words in which word I, that means the string in the word array at index I, is the predecessor of word I plus 1 only when we can form word I plus 1 by inserting exactly one character in word I without changing the order of characters. So for example, xbc from this array over here is a predecessor of the word cxbc. Note that by adding the character c to xbc, you get the word cxbc. The ask is to find out the length of the longest possible word chain or a string chain from the given array of words. We'll construct a DP algorithm to solve this problem in the DP framework, but before we move there, I want you to subscribe to my channel if you haven't done it already and hit the bell icon, because then you will be notified about new videos the moment I release them. Now let's switch to the framework. One important thing that this DP problem concerns with is the length of the words, since it is about forming word chain. You can see that the words in the array are disorganized. So first thing we'll do is sort them in increasing order of their lengths. Let me sort that now. The array has been sorted and this array over here is our new problem array. The array beneath it is the solution array, which is going to give us the length of the longest word chain. The solution array has been filled with ones which indicate the base state. We'll make use of two variables to determine the solution of each subproblem. These subproblems will help me to determine the solution of the final subproblem, which also happens to be our problem in case of dynamic programming. I have placed two variables I and j, out of which I represents this second cell, the index of which is 1, and j represents the first cell, the index of which is 0. So I represents the word xbc from this problem array and j represents xp in this sorted problem array. Now if you append c to this word xb, then you will get xbc. So observe that we got two words forming the word chain. Whether or not they will be part of our final chain, we will see. Now what we do here is we add 1 to this value from our solution array represented by the variable j and store that result in this cell. Why add 1? Because we got one more candidate in our chain, that's why. For this subproblem, the longest word chain is 2, and it is right, isn't it, if we think logically. So now I moves one cell to the right and j goes back to the 0th cell. I now represents the word cxbc and j represents xp. Check here, the lengths of both are different. So xp can't be a predecessor of cxbc. Note that the problem talks about adding just one character to the previous word. We will skip this iteration and j moves one cell to the right. The next word represented by j is xbc. We compare xbc with cxbc. Just by prefixing a c to xbc, we get cxbc. There you go. These two form a word chain. So what we are going to do, we will add 1 to the value stored in this cell represented by j, which is 2. This represents that xbc has already been forming a word chain with xp. Now we have another word in this word chain, so we add 1 to this 2. The result 3 we store in this cell. Now there are two conditions we need to check for every iteration. The length of the word should be one character greater than the word we are checking, and the order of the common characters in both words must be same. Now I moves one cell to the right and it represents the word pcxbc. J goes back to its base position and it again represents xp. Now we are going to compare these two words. So check the difference in the lengths of these two words. It is more than 1. So these two words are not going to satisfy condition number 1. Hence this iteration will be skipped. So J is going to move one cell to the right. J now represents xbc. Let's compare the lengths of these two words. So you can see that the difference between the lengths of these two words is 2, which is greater than 1. Again, these two words don't satisfy condition number 1. Hence, we'll have to skip this iteration, or I would rather say the algorithm is going to skip this iteration. Now J represents cxbc and I represents pcxbc already. Check the difference between their lengths. The difference is 1. So condition number 1 is satisfied. It gives us a signal that by adding a character to this particular word, we could get this word. But wait, condition number 2 remains, in which we have to check that the order of the common characters between the two words has to be the same. So here the order is also same of the common characters cxbc and cxbc. So now we are assured that by just adding p to the beginning of this word, we are going to get pcxbc. So they form the word chain. What we are going to do now, we are going to add 1 to this value, 3 over here, we'll get 4. This 4 we'll have to compare with the value already existing over here. We haven't done the comparison in any of the previous cases because this is a linearly increasing problem. But we could have encountered a problem in which some other problem might have given us a bigger number over here. That is why it is necessary to compare every result with the value already existing over here. The value already existing over here is 1. 4 is greater than 1, so 1 will be replaced by 4. Now I is going to move to the right. J goes back to its base position. Alright, let's compare these two words quickly. The condition of the lengths will not be satisfied for these two words, so the algorithm is going to skip this iteration. We come here, check the difference between the lengths of these two words. It is greater than 1. So this iteration will be skipped. We come over here. J represents cxbc and I represents pcxbcf. Note the difference between the lengths of these two words. It is greater than 1 again. The difference is 2. So this iteration will be skipped. Note that these words are not able to satisfy even condition number 1. J moves one cell to the right and it now represents pcxbc and I represents pcxbcf. The difference between the lengths of these two words is 1, so condition number 1 is satisfied. We are going to check if the order of the common characters between the two is same or not. So you can see that pcxbc are the common characters between these two words and the order of the characters is same in these two words. So we are now assured that by just appending f to this word represented by j, we are going to get the word I. So these two are forming the word chain. What we are going to do, we are going to add 1 to this value 4. We are going to get 5. This 5 we are going to compare with the already existing value in this cell represented by I in the solution array. So 5 is much greater than 1. 5 will replace 1. In the end, what we are going to do, we are going to traverse this array to look for the maximum value. The maximum value is 5, which is stored in the last cell of the solution array, and this 5 is our answer. So 5 is the length of the longest possible string chain or longest possible word chain which we can form from this problem array. And I'm sure that you have got the logic behind sorting this array in increasing order of their lengths, because it facilitates the algorithm in a direct manner. If you want to check the Java solution of this problem, then you can go to my GitHub link, which I have placed in the description box. With this, we have come to the end of this video. I hope you enjoyed watching this video. I hope you found the explanation good. Do give this video a thumbs up. Let me know what you think about this video in the comment section. If you have any doubts, you are welcome to put down your questions in the comment section. I look forward to help you with programming and algorithms. Until the next video, goodbye.